Hello students, welcome again. As far as this online lecture series is concerned, we are continuing chemistry of the carbon. Let's take this carbon more forward. Let me recapitulate certain things regarding this carbon. Last time we were talking about test for carbon. Test for carbon. So last time we were talking about test for carbon. In that very test, I told you people that whenever we pass carbon dioxide gas through Slakert line means when we burn carbon and its compounds, there is always the production of a carbon dioxide gas. There is always evolution of a carbon dioxide gas. The moment there is evolution of the carbon dioxide gas, that carbon dioxide gas we pass through the Slakert line. The moment we will pass this carbon dioxide gas through the Slakert line is colorless in nature. I told you people in the last video lecture, the moment we will pass this carbon dioxide gas through Slakert line, there is always production of a calcium carbonate, which is milky white PPT, white precipitate. That means this is test for carbon. Whenever you people have to carry the test for the carbon, you people have to burn the carbon compound. The moment you will burn the carbon compounds, there will be the production of a carbon dioxide gas. The moment there will be the production of the carbon dioxide gas, you people have to pass the carbon dioxide gas through Slakert line. The moment you will pass this carbon dioxide gas through Slakert line, there will always be the production of a calcium carbonate, that's limestone, and this carbon dioxide will actually turn this calcium hydroxide into milky, and we will come to know that a certain substance or a particular substance contains carbon. And this was the test for the carbon. Let me take this carbon more forward. That's now we have bonding in carbon. Bonding in carbon. This is very important topic. Bonding in carbon. As far as bonding in carbon is concerned, atomic number of carbon is 6. And we have discussed this atomic number. Let me recapitulate this atomic number. Atomic number is actually number of protons or number of electrons, and number of protons is always equal to the number of electrons. First thing, as far as bonding in carbon is concerned, atomic number of carbon is 6. That means whenever we talk, the question arises, what actually the atomic number is? Atomic number is actually the number of protons or the number of electrons. Number of protons, one more thing you people must remember, that the number of protons is always equal to the number of electrons. So let's move forward. This carbon is having atomic number 6. That means it contains 2 shells. 2 shells. In K shell, as far as electronic configuration of the carbon is concerned, in K shell it contains 2 electrons, and in L shell it contains 4 electrons. And these 4 electrons are called as valence electrons, or outermost electrons. And this shell is called as valence shell or outermost shell. So as far as carbon is concerned, carbon is having atomic number 6, having 2 shells. In K shell it contains 2 electrons, and in L shell it contains 4 electrons. Now as far as bonding in carbon is concerned, we have 2 cases. Case number 1. I told you people in the previous lecture that every single thing in this universe wants to be stable or tends to be stable. For that, carbon has to gain either it could lose 4 electrons. Carbon has to, I can say, lose these 4 electrons. It could, I mean to say, it could either lose 4 electrons to form C4 positive cation. But the problem lying with, I can say, this carbon is that these 4 electrons need extra amount of ionization energy. And I told you people in the previous lecture, this ionization energy is actually the maximum amount of energy by which we can knock out these valence electrons from their valence shells or respective shells. So in first case, as far as carbon is concerned, carbon is having 4 electrons in its last shell. Now the question arises, there is 2 possibilities as far as carbon is concerned. Rather it could gain, either it has to gain 4 electrons or it has to lose 4 electrons to complete its octet. To complete its octet. Octet means to follow the octant rule. We have discussed the octant rule. The moment it will gain 4 electrons, that means it loses or gains electrons only to achieve stability or achieve nearest noble gas configuration. I told you people regarding these noble gases, they are stable at their room temperature. Neither they lost nor they gain, because their last shell is complete. Their octet is actually complete. So as far as this carbon is concerned, here are 2 cases as far as this carbon is concerned. Carbon is having 4 electrons in its valence shell. The first case is that it could lose its 4 electrons. The moment it will lose its 4 electrons, it will gain 4 positive charge. That is C4 positive. But it needs large amount of ionization energy to knock out these valence electrons from this shell, from this last shell of the carbon. And it becomes, the second problem lying with this carbon is that it becomes difficult for the nucleus holding on to 2 electrons. It becomes difficult for the nucleus to hold on to 2 electrons only with 6 protons. The moment it will lose its 4 electrons rather from the last shell, then it will have only 2 electrons, and it will be difficult for the nucleus to hold on to 2 electrons with 6 protons in its nucleus. For example, as far as nucleus is concerned, nucleus contains neutrons plus protons. And I told you people, proton number should always equal to the electron number. Now, if carbon loses 4 electrons, that means it will have only 2 electrons, that too in the K shell. That means number of protons equals 6 and the number of electrons 2. And it will be difficult for the nucleus of the carbon to hold 6 electrons in its nucleus onto 2 only electrons. That means it can't lose 4 electrons. Now the first thing, it can't lose 4 electrons. Now the second case. Case number 2. case second, it could gain 4 electrons. It could gain 4 electrons to form C4 negative anion. But it would be difficult for nucleus with 6 protons to hold on to 10 electrons. That means 4 extra electrons. In case second, I told you people, as far as this carbon is concerned, in K shell it contains 2 electrons. In L shell it contains 4 electrons. And I told you people that there are 2 possibilities for the carbon. Either it could have to lose 4 of its electrons, or I discussed that very case. Now the second case is that it could gain 4 electrons to complete its octet. That means it will gain 4 electrons and there will come 8 electrons in its valence shell. So that means it will achieve nearest noble gas configuration. But for that, the problem lying with this carbon is that it could gain 4 electrons to form anion, C4. It will gain 4 electrons. It will form C4 negative anion. But it's difficult for the nucleus of the carbon. This is nucleus. Nucleus contains neutrons plus protons having positive charge. In its first shell, it contains 2 electrons. And in its last shell, it contains 4 electrons. The moment it will gain 4 more electrons, it will be difficult for the nucleus, because I told you people, proton number should always equal to the electron number. That means this is atomic number. So the moment it will gain 4 more electrons, that means it's having only 6 protons, 6 protons in its nucleus, and it will gain 4 electrons. That means 4 plus 2, and will gain 4 more electrons. That means it will gain 10 electrons. And it will be difficult for the nucleus to hold these 4 extra electrons. 4 extra electrons in its nucleus. So in case second, I told you people, it could gain 4 electrons to form 4 negative anion, but it would be difficult for the nucleus with 6 protons, because carbon is having 6 protons in its nucleus. Protons to hold on to 10 electrons, that's 4 extra electrons. So case second, so that means it can't gain 4 more electrons. Now the third case, as far as this carbon is concerned, so only funda, what carbon can do next is that it can share its 4 valence electrons with other atoms or elements to achieve nearest noble gas configuration. Like, this is carbon. In first shell, because atomic number of carbon is 6, in first shell it contains 2 electrons. In second shell it contains 4 electrons. Now, I told you people that it will share its 4 valence electrons. 4 valence electrons. These are 4 valence electrons. For example, this is in case of methane. In case of methane, this is carbon having 4 valence electron. This is 1 valence electron, this is 2nd valence electron, this is 3rd valence electron, and this is 4th valence electron. It will share its 4 valence electrons with 4 hydrogens. Like this is 1 hydrogen, this is 2nd hydrogen, and this is 3rd hydrogen, and this is 4th hydrogen. hydrogen is having atomic number of 1. That means its valence shell contains only 1 electron. That means this is like this, like this, like this, like this. Now the carbon, I told you people, neither it is in a state to lose or gain 4 electrons. Now it will share its 4 valence electrons with other hydrogens to complete its octet or to achieve nearest noble gas configuration. For example, this is one electron of the hydrogen and 1 electron of the carbon, and they will share this like this, like this, like this, like this. And there will occur mutual sharing between carbon and hydrogen, and the bond formed between this carbon and hydrogen by mutual sharing of electrons, and this particular type of bond is called as covalent bond. Now, what's covalent bond here? The question arises, what's covalent bond? Covalent bond is actually that bond which is formed between the two atoms by sharing of electrons. It's sharing of electrons. Hydrogen provides 1 electron and carbon provides 1 electron. Like this. And this bond is called as covalent bond. This bond is also called as covalent bond. This bond is also called as covalent bond. And this bond is also called as covalent bond. Like this. 1, 2. Now, look, see the carbon. 1, 2, 3, 4, 5, 6, 7, 8. This carbon becomes stable like this. And this hydrogen, I can say hydrogen is having 1 electron in its valence shell. That means it needs 1 more electron to complete its octet. That means duplet number of electrons. Carbon, it will take 1 electron from carbon and 1 from itself. That means it becomes stable, hydrogen becomes stable, this hydrogen becomes stable, and this hydrogen becomes stable, and this hydrogen becomes stable. Now, the only funda behind bonding of the carbon is that carbon always form bonds, but those bonds are covalent in nature. And covalent in nature means this carbon always form bonds by sharing of electrons, by sharing of its 4 valence electrons which are in the valence shell. Let me quote one more example. This is carbon. If it will bond with another carbon, just like this. This carbon is having 4 valence electrons. 1, 2, 3, 4. 1, 2, 3, 4. Look, I told you people that this carbon always forms bonds with other carbons as well by sharing of electrons. It will share this very electron with this carbon, thereby forming carbon-carbon bond. Now look, it will achieve, this carbon will also achieve nearest noble gas configuration, and same is the case with this carbon, like 1, 2, 3, 4, 5, 6, 7, 8. Now it achieved nearest noble gas configuration like this carbon. Now, as far as this carbon is concerned, 1, 2, 3, 4, 5, 6, 7, 8, like this. Now the question arises, what type of bonds carbon always forms? It's actually the covalent bonds. Covalent bonds which carbon forms by sharing of electrons. One more example. This is a carbon. And as far as this carbon is concerned, this is C2H6. This is ethane. See, 1 carbon, 2nd carbon. In its last shell, it contains 4 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now, how many? We have 6 hydrogens. 1 hydrogen, 2nd hydrogen, 3rd hydrogen, 4th hydrogen, 6th hydrogen. Just like this. 1, 2, 3, 4, 5, and 6. Look, this carbon and this carbon will form a bond that's covalent in nature. Covalent bond. This carbon will provide 1 electron, and this carbon will provide 1 electron, and this bond is always covalent in nature. and this carbon will share one more electron with this hydrogen, thereby stabilizing the hydrogen. This, thereby stabilizing this, one more electron from hydrogen, stabilizing this, one more electron from hydrogen, stabilizing this, one more hydrogen, stabilizing this, one more hydrogen, stabilizing this. Now look, 1, 2, 3, 4, 5, 6, 7, 8 means this carbon becomes stable. It will achieve nearest noble gas configuration. Now as far as this carbon is concerned, 1, 2, 3, 4, 5, 6, 7, 8. Now this will get stable like this. So from the conclusion, the bottom line of the story is that carbon always form bonds, and those bonds are covalent in nature, and it's always formed by the sharing of its electrons, 4 electrons which are in its valence shell. Thank you for watching this, and we will continue this carbon in the next video lecture. Thank you.